Welcome back, geometry students. Here I am in GeoGebra, and you can see that what I've created here is the old type of triangle we looked at in a previous lesson, where I have 3 points, and then the midpoints between those points. That's what F, D, and E are on the sides here. And then what I've done is I've connected each vertex to the opposite midpoint. Now remember, this helps you to find this point here, which is the centroid or center of gravity of the triangle. Now, I just wanted to show you something. If I were to compare the angles at each of the vertices, but not the angles of the triangle itself, I'm talking about these smaller angles between the median and the sides of the triangle. Notice that the median is not actually an angle bisector. You might have been wondering when I started this lesson and was talking about angle bisectors of a triangle, if this is something that we already did when we made medians. But notice that the median, which always goes from one vertex to the midpoint of the opposite side, it cuts each angle in unequal ways. So this angle here of the triangle, when I add these two angles together, I see it's somewhere around 51 degrees, a little more than 51 degrees. Notice that 30 degrees are here, 31.13 degrees right here, and 20.1 degrees in this little space here. It's not cut equally. And the same is true of all three angles of my triangle. When I look at the angle between the side and the median from that vertex, uh, it doesn't cut that angle evenly. So what we're going to do is in GeoGebra, we're going to actually make a triangle with angle bisectors that evenly cut. And we're going to do this based on one of the example problems at the back, the lesson practice problems, which asks us to use a compass and a straight edge to find the incenter of a triangle whose vertices are at -3, 1, 3, -2, and 2, 4. Let's put vertices in those places. So what I'm going to do is I'm going to clear what we have here. It's going to ask me if I want to save. I'm just going to say to discard because that's easy to make anyway. And we're going to put points in 3 places, and then later on we won't have to do this again. So the 3 places we need points are -3, 1, bam. We need a point at 3, -2, bam. And then we need a third point at 2, 4, bam. There we go. All right, so I've got my 3 points. And to make this a triangle, I'm going to connect those 3 points with segments. So I'm going to scroll down in my tool belt here. I'm going to find the segments option. And I'm going to click the first point, the second point, the first point, the second point, the first point, the second point. And I have my triangle. And my goal here is to find the incenter of this triangle. Now, the incenter is made by finding the place where the angle bisectors cross. Now, I'm just going to tell you, when you start using bisectors or parallel lines or perpendicular bisectors or perpendicular lines in GeoGebra, things get messy, but they never get as messy as they get with angle bisectors. Because look what this does, okay? Hey, I want the angle bisector. I would like one little tiny segment inside my triangle, please. Oh, but I can't get it inside my triangle. It's going to continue onward. And not only that, it's going to add a completely extra irrelevant line here that's perpendicular to the angle bisector. So I've got this extra line out here. It'd be really nice to get rid of that. I'm going to show you how we're going to do that in a little bit. But let me just click on all 3 pairs of lines and add all 3 angle bisectors. So I do have my angle bisectors inside here, but I have a lot of extra lines on the outside. I have extra triangles being drawn. This is too much. So I'm going to go back to my pointer tool. I'm going to click on lines that I don't need. I don't need these perpendiculars to the angle bisector. And all I'm going to do to get rid of them, if I try to trash them, I believe it gets rid. Let me just do this. I think it gets rid of my whole angle bisector. Yeah, I can't do that. What I can do is I can click on these lines that I don't want, and I can change their color. Uh, let's see. I'm going to change their color to white, and then that should get rid of them. There they go. All right, so we're going to do that for this one, and we're going to do that for one other for this one. There. Now they are gone from my view, and that's good enough for me. You can still see their shadow kind of on the graph in the background, but eh. And the other thing that I'm going to do is I'm just going to change my angle bisectors to dotted lines, and that allows me to see my original triangle much more easily. Okay. Okay, there we go. And then the last thing I'm going to do is I'm going to put a point on my in center. So if I just really carefully hover to that point, now I am going to show you by adding a ton more lines to this again, but I need to show you what an in center does. I'm just going to tell you, if I were to try to measure this length and this length and this length, what I would find is they would not equal each other. Looks like they might equal each other, but they don't. They're going to be a little bit off from one another. They're really not that far off from one another, but I thought the incenter was supposed to be the same distance from all three sides of the triangle. So shouldn't these be equal? Well, here's the thing. It is equidistant from all three sides, but it's equidistant from all three sides from the closest point. And these are diagonal to the line. They're not perpendicular, so they don't actually go to the closest point. So if I wanted to, what I can do is find a perpendicular line and add a ton more extra lines to my drawing. So just bear with me. We're going to do this, okay? So I want a line that's perpendicular there, a line that's perpendicular there, and a line that's perpendicular there. And it's really important when you make drawings in this that you make them in such a way that you can keep track of what's going on. So I'm going to change these to a really light color. We'll do like a pastel blue. And then I won't see them as distinctly as when they were just this dark black color. So now notice that these three lines are not too far away from the angle bisector lines. What this is the line from the in center that's perpendicular to this side. This should be the shortest distance between the in center and this side. This is the shortest distance. Here is the shortest distance here. The other thing that we can do in GeoGebra is I can measure things. So I'm going to measure the distance or length from D. Oh, I maybe need to put a point here. Let's see. Nope. From D to here and from D to here. There we go. Okay, so notice all of these distances are exactly the same. Now, I don't want to adjust this triangle too much because this is the triangle that we need to draw for one of our problems, but I am just going to temporarily take one of the vertices and move it around a bit just so we can see what happens when we do so. So let's take A. We're going to move it back to -3, 1, I promise. But let's see what happens to these three segment lengths as I move this around. Notice that no matter what, I can do anything I want to this triangle, and those three segment lengths stay the same. And that is what I'm trying to prove there. All right, so we're going to go back to -3, 1. My in center is at a really strange place. I was expecting that it was going to be at uh, a perfect intersection of 2 points on my grid, and it is not. Here's the thing. I would have really loved it if this intersection was at one of the actual grid points. Like, it would have been nice if it was 1, 1. Yay, we have a perfect point where the in center is. Unfortunately, that's not the case. And for most triangles, the in center is not going to have any integer relationship to the 3 points. So we are just going to have an in center at 0.68 if I round it and 1.14. By the way, just when you're working in GeoGebra, if you want to round things easily, all you need to do is go over here to settings on the right side, and then you click on the little gear again, and you can choose to round to 2 decimal places. And that makes it a lot easier to look at the numbers that you have on your screen or over here. So see that I've got this point D that is 0.681.14. That's my in center for this triangle. And we're just going to remember that for when I work the example problems a bit later. I'm going to clear my work with the in center because we don't really need this anymore. And we're going to use the tools to create a circumcenter. Once again, I'm just going to create a triangle. And this time I'm just going to choose any 3 points for my triangle. And then I'm going to connect those with segments down here. Click, click, clickety, click, clickety, clack. Okay. And now what I need to do is find the perpendicular bisector. Look, I have a perpendicular bisector option right here. So I need to select a segment, and it'll give me a perpendicular bisector. Perpendicular bisector, perpendicular bisector. I must have made a right triangle here because my perpendicular bisector is on the hypotenuse. That was not what I intended. So we're going to move things around a little bit anyway, but kind of cool that I made a perfect triangle without trying. Without trying on a triangle. All right, so I'm going to make all 3 of these sides dotted, these perpendicular bisectors dotted, so that we can tell them apart from the triangle. And then I am going to move the vertex of my triangle a bit so I can see that circumcenter here. And then I'm going to put a point on our circumcenter. Now, I need to connect that point with a segment to each vertex because that's what we need to be able to see here. So I'm going to go down to segments, and I'm going to do A to D, B to D, C to D. There we go. And then I'm going to go up to distance or length, and we're going to see if we can measure the length of these 3 segments. And we should see that the circumcenter makes it so that we are all 3 of our segments connecting the circumcenter to the vertex are the exact same length, and that's what we see. Okay, so notice that these circumcenters don't have anything to do with the vertices. This one just happens to go through this vertex, but the other 2 are not passing through vertices. They're just perpendicular bisectors of one of the sides of the triangle. And when we do that, when we make perpendicular bisectors for each side, we get this circumcenter. And the circumcenter has another cool feature. Okay. So if I were to draw a circle on here, way at the bottom, I have an option for circles. I'm going to start by selecting the center point of my circle and then another point. And notice that all 3 points on my triangle are on the circle. So I've just inscribed my triangle in a circle. That's a really cool feature of the circumcenter. It lets me inscribe my triangle perfectly. Okay, so this is the circumcenter. And notice it has all of the features that we said it will have. One other thing I'm going to do is I'm going to change these interior lines that I drew that are the same length so that they are also dotted. We'll choose a different type of dots than my original ones. So we'll go with the dashed lines instead. Ooh, dashing. All right. And then I'm going to move this around again. Now, let's see if we can make an obtuse triangle. Notice that when I have an obtuse triangle, my circumcenter is outside the triangle, but I still have a circle that can contain all 3 of my outer points. If I have a right triangle, like this one, now on a right triangle, my circumcenter is somewhere on the hypotenuse. And then if I make it an acute triangle, my circumcenter is inside my triangle. But a couple of things are always true for all of these. These 3 values are always the same. They're equal to each other. And I always have an inscribed circle around the outside of my triangle.